you, my friends? I'm continuing the algebra course lectures, and we are here in the middle of factoring. Last time I have finished lecture 10, covering factoring two terms. Now, this is lecture 11, factoring three terms. Just to remind you, if you need to go and check any lecture, please go and visit the playlist algebra course lectures. All right, lecture number 11, factoring three terms. I mentioned this before. In the factoring, we have three lectures, 10, 11, and 12, as you can see. Also, if you did not see lecture 10, factoring is important to understand before you start doing any question. Factoring is to write the expression in product form. That's a simple definition here. You have to write the whole expression, like this one, x cubed minus 8 in two brackets or three brackets, whatever. So factoring, we go like this. B squared minus 25 is the factoring is this, B minus 5, B plus 5. If you multiply these, we call it expanding. So expanding is the opposite of factoring. Look here, we have 1, 2, 3, 4 terms. We need the answer like this. We cannot leave any number outside the brackets. So two terms, this is lecture number 10, three terms, lecture number 11. We are doing now 4 terms or more. We have lecture number 12. Now the steps in the factoring, the first step always we look for greatest common factor if there is any in all terms. Then after we take the common factor, which is easy, we see how many terms, 2 terms, we can use the formulas. You have to check lecture number 10, 3 terms we are doing now, 4 terms or more, this is grouping, and then you can check at the end, can we factor more? Because you have to factor the expression completely. 3 terms. Now in the 3 terms, maybe this is a little difficult. 3 terms you have to check. You have to look at the 3 terms. 3 terms we call it trinomial. 3 terms, trinomial. So the trinomial can be perfect, or sometimes it is not perfect. Let me give you here 4 examples. M squared plus 6m plus 9, that's an expression. Can we write it as m plus 3 squared? Now look here, this is the basic formula here. These are the formulas. So the squared here, m squared is the same as x squared. 2xy, so this is 2 times 3 times m, and y squared is 3 squared. So yes, this one is equal to this one, because x squared plus 2xy plus y squared is equal to x plus y all squared. That's perfect square trinomial, perfect square trinomial. If you have a minus in the middle, plus at the end, always we have to have plus, remember that. It will be x minus y all squared. So these 2 formulas, we call them perfect. Perfect, these are the examples. M squared, 6m. You have to check here in the middle, 2xy, we call it the middle term. So m, 3 from here, 2 will be 6, yes. How about this one? 10t squared minus 10t plus 25. So there's a minus, so we put the minus here. The square root of t squared is t, square root of 25 is 5, but you have to check here 10. 10 is 5 times 2. Now look here, very similar, y squared, 10y plus 9. See, very similar to number 1. But this is not perfect. See, y squared like m squared. You see that? Plus 9 plus 9. You have to check the one in the middle, 6m. 6m is coming from m, 3, and 2. So this one, y, 3, and 2, it's not 6, it's 10. Any number not 6 here, this is not perfect. So we can factor it. I will show you how. we can factor this y plus 1, y plus 9. Now this one also, 3d squared plus 4d minus 4. Since we have here minus, since we have the last number minus, it's not perfect. So that's a trinomial, not perfect. You see, not perfect. So this is the most important slide here, please. When you study factoring three terms, you have to understand this slide first. When you see three terms, you have to decide, is this perfect or not perfect? Clear? If it is perfect, use the formulas. If it is not perfect, wait a few minutes. I will tell you what to do. Now, what to do is check the leading coefficient, LC, this is the leading coefficient. You see here, the number, the leading, if LC, the leading coefficient, LC is the leading coefficient. If this is 1, we use one method. If the leading coefficient is not 1, we use another method. So three terms is not that easy. It's not straightforward. You have to look, think, then decide. I hope, is this clear now? One more thing, I'll just say m squared plus 6m plus 9, that's perfect because 3 times m times 2 is 6. Here, y squared 10y plus 9, not perfect because this is 3, this is y, and this should be 6y. If we have 10y or 7y or minus 8y, it is not perfect. Now, to find the factoring here, just wait a few minutes. I will show you what to do. Let's start with example 4. We have 4 parts. Look carefully, please. E squared minus 14e plus 49. 25k squared minus 40k plus 16. Let's take one by one. Do you think the first one is perfect? How do you check? This one, take the square root, e. Take the square root, 7. 7 times e times 2. From where we get the 2? From the formula. I'll go back. See the formula here, it has 2. So always you have to think of the 2. This 2 is coming from the formula. So that's perfect? Yes, it is perfect. That's perfect. Now let's see 25. 25k squared, I can make it all squared here. So 5k, I can make it all squared. And then this is 16. 16 means 4 squared. If this is 15, you see this one? If this one here is 15, that's not perfect, so we stop. So let's see, 2 by 2. The first one, I check the middle term. You see, I told you, 2xy, 2 times e times 7. That's 14e, correct, yes. Let's see here, 25k squared. You play with this number here. You make it 5k all squared minus 40. 16 is 4 squared. Remember, it should be plus. So check the middle term. We call it middle term. 2xy, 2 times 5k times the 4. This is 40k. Yes, it is correct. Now we don't care. Sometimes a minus, sometimes plus. In these two examples are minus. Let's see example number 3, please. Did you try example number 3 and 4? X squared plus 22x plus 121. Is this perfect? Now, the last one may be a little tricky here. What do we do? 75. You know, 75 is ugly. It's not perfect. And there is an M. What do you do in number 4? I cannot hear you. Are you saying common factor? Yes, that's a common factor here. We take a common factor in number 4. See, this is number 3 is easy. Check the middle term, 2xy. See, 2, this is x, the square root here. Square root of 1 to 1 is 11. 11 times 2, 22x. That's correct. And we put plus here. Y plus, the middle term has plus. And this one always it should be plus. Now here, this it looks ugly. See this example? 12m cubed, 60m squared, 75m. I can see there is a common. I told you, step number 1 in the factoring, check if there is a common factor. Always. So take 3m out. 3m here becomes 4m squared. 60 if you take 3 out, 20m. 75 if you take 3, you get 25. So let's check the one in the middle here, in the bracket, the middle term. This is 2m here, all squared. This is 5. 2 times 2m times 5, that's 20m, correct? So we put here 2m plus 5, which is x plus y squared, and there's a 2m. That's all the answer here. Now, is this clear? So again, this is the basic slide. If you have 3 terms, check if it is perfect. If it is perfect, use the formulas. If it is not perfect, I will show you now 2 methods. Now, this is not perfect. You see, this is big here, not perfect. If the factoring trinomial is not perfect, leading coefficient is 1. Use this method. See the leading here, the leading coefficient, this one here, the leading coefficient. It's the coefficient with the highest power, x squared plus 7x plus 12. If this is 1, easy. See, if it is not perfect, then the leading coefficient is 1. That's easy. Use sum and product. In the middle here, the coefficient of the x is the sum, and the product here is the last number, the constant. So try to think in your mind, find 2 numbers, their sum is 7 and the product is 12. Just from your mind, find 2 numbers, their sum is 7 and their product is 12. These numbers are 3 and 4. So I write x plus 3, x plus 4. See, if you multiply this, you get this is the question. Easy? I hope. So again, when you have 3 terms, this is 3 terms, check if it is perfect. Is this perfect? No, because of the 12. 12 is not perfect. It's not like 16 or 25 or 49, etc. Now let's see question number 5. Factor the following trinomials. M squared minus 17m plus 60. See, we can see here 3 terms. We ask the first question, is this perfect? 60. It is not perfect. So if it is not perfect, I go directly to the leading coefficient here. Is this 1? Yes. This is not 1. I have to make something here. This is 1. See this one here, minus 3. Because of the minus, even if we have minus 9, this is not perfect. It should be plus 9. All right. Let's see now the solution. Try to think here, please. Find 2 numbers. Their sum is minus 17 and their product is 60. See the product 60 and the sum is minus 17. That means the 2 numbers are negative, because when you add them negative and negative, you get negative. When you multiply them, you get positive 60. So let's see the numbers here. Minus 17m. So these numbers are minus 5 minus 12. Easy, we can do. M, the variable here is m minus 5, m minus 12. Now, if you want to learn more, please, you can multiply these at home if you have some free time. Multiply m times m times minus 12, minus 5 times m minus 5 times minus 12. You get this number here, expression. So this is the leading coefficient 1. Now here, we see common factor. See, that's a little trick here. We see a common factor. 2k cubed minus 4k squared minus 30k. There is a 2 and there is a k. Now inside we have k squared minus 2k minus 15. Now the leading coefficient here is 1. And this is not perfect. So what are the two numbers? Their sum is -2, their product is -15. These numbers are 3 and -5. If you add them here, add 3 minus 5, you get -2. Multiply them, you get -15. So 1 plus, 1 minus. So the final answer here, the 2k is one, the answer here, part, k plus 3 and k minus 5. Now this one, x squared minus 2x minus 3. This is not perfect. Yes, not perfect. The leading coefficient is 1. Yes, the leading coefficient is 1. So let's see, two numbers, their sum is -2, their product is -3. So these numbers are -3 and 1, because when you add -3, add 1, you get -2. If you multiply, you get -3. So the final answer here is in the factoring, x minus 3 from here, x plus 1. Easy, easy. Now, I said here, remember this. You see this one, x squared minus 2x minus 3. I said remember it for a reason. Remember, write it down, please, on a piece of paper. I will write it also here. X squared minus 2x minus 3. Just remember it. Let's go to the next example here. It looks difficult example. Trinomials with two variables. See, we have x and we have b. X squared minus 2bx minus 3b squared. Now it looks difficult, but also we check the three terms. This is not perfect, and the leading coefficient here is 1. So let's find two numbers, their sum here. This is the sum here, coefficient of the x minus 2b. Their product is all this number minus 3b squared. So these numbers are minus 3b and b. See the one I said, remember it, x squared minus 2x minus 3. It's the same question, but I added here b squared and then b. So the final answer is the same, x minus 3b, x plus b. So these are the numbers. Instead of minus 3 and 1, it's minus 3b and b. When you add, you get minus 2b. And when you multiply, you get minus 3b squared. Now, let's see two more difficult examples. Two variables here. X squared minus 7yx minus 18y squared. How do you start there? Try to think, suppose this is your mind here, the sun. Try to think of x squared minus 7x minus 18. Just try to forget about y squared and y. Then you can put it at the end. Think of this. That's easy. X squared minus 7x minus 18, which is the same question as a part, but only you have to include the y in the answer. All right, let's see. What are the two numbers here? Can you check, please? Two numbers, their sum is minus 7 and their product is minus 18. Can you find these numbers? Write it down and check. You can pause the video, please, if you like here, and try these two, A and B, and then you can check the answer. So each one on a separate slide. So this is what I need here. If you have x squared minus 7x minus 18 only without the y, it's x minus 9, x plus 2. So the two numbers are minus 9 and 2. Now, when you have the y, it's the same. Find the sum, it's minus 7y, and find the product minus 18y squared. So what are the numbers? Minus 9y, 2y. You see here minus 9 and 2? Just include the y because we have here y squared and here we have y in the middle. So this is the question here. X squared minus 7yx minus 18y squared. To factor it, it's x minus 9y, x plus 2y, very similar to the one in the sun here. Very similar. All right. Can you try the second one, please? 2a cubed minus 18a squared b plus 36ab squared. Try this one, please. Now, if you have finished, Let me show you. Now, notice here, there is a common factor. 2 and 18 and 36, there is a 2. A cubed, a squared, a, there is an a. So 2a is the common here. See, that's the question. 2a is a common. Then inside we have a squared minus 9ba plus 18b squared. Now, try to think of this. A squared minus 9a plus 18. Think without b squared and b. Only you take a squared. Now find the sum is here minus 9b and find the product is 18b squared. These numbers are, you can ask the same question here. Find two numbers, their sum is minus 9 and their product is 18. These numbers are minus 3, minus 6. And here you can include the b because we have b in the middle, b squared at the end. Now the whole question is, this is b part here. This is the whole question. How to factor it? 2a is part of the answer. Remember please, 2a is part of the answer. A minus the 3b here, or 6b. You can take anyone first, no problem. So a minus 6b, a minus 3b. It's the same. You can put a minus 3b, a minus 6b. The product here is commutative. Now, try at home. See, try at home questions and extra questions and practice. Please, you can find them in another video called Additional Solve Questions on Factoring. But here you can try it at home, please. And then the answers only there. You can try and the answers are provided. If you get the answer correctly, you know how to do it. Excellent. If not, you can visit the videos on Additional Solve Questions on Factoring. Now we come to the last part here for 3 terms, the most difficult, ugly part students do not like. 3 terms, we have 3 terms, not perfect, and the leading coefficient is not 1. That's the hardest you can get. See, like this one, look at this ugly example. 6x squared plus 7x plus 2. See, it's not perfect, for sure not perfect, because there is a 2 here. And the leading coefficient is not 1, so this is 6. That's the most difficult you can get. So I will call the method here slide and divide. SDM, slide and divide method. So look here at the example. I will show you 2 ways you can do this. There's another way also. No need for that. Slide and divide is one method, and I will show you a quick method after I finish here, after a few minutes. So, if the leading coefficient is not 1, what do? We slide. That means we take the leading coefficient and the constant and we multiply them. If you multiply 6 and 2, what do you get here? 12. Still, this number here in the middle is the sum. But we don't say the product is 2, you see? Unless this number is 1. So I take 6 and 2, 12. Now find 2 numbers, their sum is 7 and the product is 12. Well, these numbers usually are easy. Again, the sum is 7 and the product is the 12, the leading coefficient and the constant term. Then multiply them. So this is the sliding, you slide. So these numbers are 3 and 4. So I put x plus 3, x plus 4. Remember, this is not the final answer. Remember, this is not the final answer. Then you have to divide the numbers 3 and 4. You see these 3 and 4. Divide by the leading coefficient here, 6. So it becomes x plus 3 over 6, x plus 4 over 6. Then you simplify. 3 over 6 becomes half. 4 over 6 becomes 2 over 3. Then the first factor here, I multiply by 2. So this becomes 2x plus 1. And this one I multiply by 3. 3x plus 2. That's the answer now. 2x plus 1, 3x plus 2. If you multiply these, try 2x times 3x, that's 6x squared. 2x times 2, 4x. 1 times 3x, 4x, and 3x, 7x. 1 times 2 is 2. Well, this method, we call it slide and divide method. I will show you 2 more examples on slide and divide, then you can try yourself. Let's see. 2 examples here, very nice. 5k squared plus 13k minus 6 and 12y squared minus 5y minus 2. Let's take one by one, please. I advise you at this moment to pause the video for a minute or so and try the first one here, please, by using slide and divide method. Okay, I hope now you have finished. Let's see. 5k squared, 13k. So I multiply 5 and minus 6. That's minus 30. And this is 13 here, the sum. So what are the two numbers? Their sum is 13 and their product is minus 30. These numbers are 15 and minus 2. Only one answer you should get here. So I write k plus the 15, you see here, k minus the 2. Then what is the leading coefficient? 5. So I divide the numbers 15 and 2 by 5, like this. 15 over 5, 2 over 5. Then I simplify. 15 over 5, you divide by 5, get 3 over 1, leave it. Leave the 1 there. K minus 2 over 5 already simplified. So multiply the first one by 1 because of this denominator. And then the second one multiply by 5. So you get k plus 3, 5k minus 2. Try to check. K times 5k is 5k squared. K times minus 2, minus 2k. And here we have plus 15k, which is 30, and this is minus 6. That's the answer here. Can you try, please, this one? Remember, sometimes you can have a more difficult question. You can have a common factor. You can have a common factor and also slide and divide method. So be careful. Okay, please try number 2. 12y squared minus 5y minus 2. I hope you can get the correct answer. And then I will give you another method very quick, if you like it. So let's see. Now, example 7, second part. 12y squared minus 5y minus 2. Minus 5 is the sum. The product, multiply 12 and minus 2. What is this? Will be minus 24. What are the numbers? Their sum is minus 5 and their product is minus 24. Is this minus 8 and 3? Just try to add here. See, to get these numbers, you have to think only of the numbers. One answer only there. Minus 8 and 3, if you add, you get minus 5. If you multiply, you get minus 24. So we write y minus 8 from here, y plus 3. Remember, this is not the answer. That's part of the answer on the way. Divide the numbers 8 and 3 by 12, the leading coefficient. So 8 over 12, 3 over 12. Simplify now. This one, you divide by 4, 2 over 3. Divide by 3, 1 over 4. Multiply the first one by 3, so you get 3y minus 2. Multiply the second one by 4, 4y plus 1. Let's check, please. 3y, 4y, 12y squared, it's okay. 3y times 1, 3y. Minus 2, 4y multiply minus 8. So you get minus 5 because we have plus 3y, and then minus 2. That's the answer. Now, 3 examples I gave you in details how to use slide and divide method. Now, look at this gift. I call this a gift. Trial and error method. There is a method in mathematics. If you like it, I usually do it, This is another method to factor trinomial with the leading coefficient not 1, like this one. See, like the last 3 examples we did? But some students, some people do not like this method because you have to think a lot of the possibilities. Okay, here, let's take 6 and find the factors. 6 and 1, 2 and 3, or 3 and 2. Take the minus 5 and 1, 5 and minus 1. Then you have to try. See, it's called trial. Trial, we try. If you make an error, you try again, try again, try again, until you get the answer here. So 6x squared, I can try 2x, 3x, or 3x, 2x, or 6x, 1x. Then I take the 5, try minus 1 and 5, 1 and minus 5. Then you have to multiply until you get 7x in the middle. I don't know, did you like this method? I usually do it. I usually use this trial and error method. If you are good in math, you can use it. If you are a little weak, I advise you to start with slide and divide method. Then when you are expert, you can use this method. You get the answer maybe in few seconds. Now, try at home 5. You can find the answers. The answers are there here. So you try at home 5. And then extra question, very nice, tricky question. We need to factor this. 10, 3t minus 1 squared, 11 times 1 minus 3t minus 6. And then this is extra question number 3. The answer is there. Try at home 6. Also, the answers are there. Extra question number 4. Also, the answer is there. So you have many questions in this lecture 11 as examples. I did it in details. I left some questions for you to practice extra or try at home. You can find these answers in additional solved questions in factoring. Now, this topic is to be continued in algebra course lecture 12, because this is lecture 11, what we did today. So lecture 12 will be next, about factoring 4 terms or more. Thank you very much for watching. I hope I can see you in another video with another topic. Just to remind you, this is lecture number 11 on factoring 3 terms. Thank you very much.